This is an inscribed example where we have one figure inscribed in another. So we need to find the dimensions and volume of a right circular cylinder of maximum volume. So we're maximizing the volume of a cylinder inscribed in a sphere with radius 14 centimeters. So we need to find a picture. So I have a sphere, and inside of that sphere, I'm going to inscribe a cylinder. Okay? So, and we're maximizing the volume of our cylinder. So volume of a cylinder is pi r squared h. Okay, so we're maximizing that. So r is the radius of the top, that's what r is, and height is this whole distance. The only thing that they give us is they give us, from the center of our sphere, the radius of our cylinder to be 14. So we have a right triangle here. So that is half of our height. The reason I need that is I need this volume equation in one variable. I know that r squared plus h squared over 4 equals 14 squared, which is 196. So since I have an r squared in this volume equation, I'm going to solve for r squared in this other equation. Okay, so now volume equals pi r squared h. R squared was 196 minus h squared over 4. Then I simplify that. And I'm going to distribute the pi in and the h in. Okay, so that's our volume equation. Now think about what we have to range between. R is between 0 and 14, and h also has to be greater than 0, but h is going to actually be less than twice of 14, which is 28. Okay, let's find the derivative of our volume function in relation to h to find our maximum. So we have 196 pi minus 3 pi h squared over 4. I set that equal to 0. So h squared, simplifying all that out, is 784 over 3, which means that h is going to be plus or minus root 784 over root 3, which works out to be 28 over root 3. Now I need to determine that, or verify that that's a maximum. So let's find the second derivative and use our second derivative test. So our second derivative ends up being negative 3 pi h over 2. I evaluate that second derivative, at my critical point in the first derivative. And I don't really even care what that is. I just need to know whether that's positive or negative. That is going to be less than 0, which means I'm concave down, which means my critical point is a max. Max at h equals 28 over root 3, which in your calculator rounded to 3 decimal places is that. Okay, and it's a max by the second derivative test. Because f double prime of our h value was less than 0, where v prime of h equaled 0. So I have my h. I need to know the dimensions and volume. So once I know h, I plug back into our r squared formula. I plug in h there, and I got in my calculator 11.431 centimeters. And then I plug into my volume equation r squared and h, and when I plugged that in, I got a volume of 6,636.166 centimeters cubed. And again, make sure that you are rounding to 3 decimal places.